Welcome to qnawire.
Hello and welcome to problem 16 of chapter 2, section 4. Here we're asked to solve the given initial value problem and determine how the interval in which the solution exists depends on the initial value y naught. We're given the initial value problem y prime is equal to t squared all over y times 1 plus t cubed, and of course y value at 0 is equal to y naught. So let's start off by solving this differential equation. Since it's separable, we can get the y into the left side, so we'll have y prime times y is equal to t squared over 1 plus t cubed. Here we can just take the integral of both sides, and we'll have 1/2 y squared is equal to the integral of t squared over 1 plus t cubed. Let's just use u substitution. So u is equal to 1 plus t cubed for du is equal to 3t squared. So we're left with the integral of dt. So we're left with the integral of u over du times 1/3, I believe. Like that. And of course, this is just a natural log. So we'll have back to green, of 1/2 y squared is equal to 1/3 the natural log of 1 plus t cubed plus c on the outside. From here, let's just solve for y. So we can multiply by 2 and get 2/3, and then we can just take the square root. So y is equal to square root of 2/3 the natural log of 1 plus t cubed plus c. All right, and since we have an initial value, we can plug that in now. So we let y naught be equal to the square root of 2/3 times the natural log of 0, or the natural log of 1. The natural log of 1 is 0, so times 2/3, also 0. So we're left with y naught equals the square root of c, so that c is equal to y naught squared. And from that, we can directly substitute it in to, let's just substitute it into that line. So we'll have plus y naught squared. And as we can see, this actually constrains y naught into being strictly non-negative. Let's get into this. There are two. There's actually only one way that y naught would change the possible value of the initial value problem, and that's if it makes the square root negative. So let's solve for that. We have blue, so y naught squared plus 2/3 times the natural log of 1 plus t cubed must be strictly greater than or equal to 0. And here we can just solve for y naught by subtracting the natural log term and taking the square root. So y naught must be greater than or equal to the square root of 2/3 natural log of 1 plus t cubed. And that is the solution to this initial value problem. As long as y naught is greater than this square root term, then we'll have a valid interval. And that concludes the problem.